My name is Tobias, and I'm going to talk to you about Async AWS. And I'm going to tell you what we were thinking when we took a look at the official AWS SDK and thought, hey, we can make this better. It's only have 100 million downloads, and it's been around since like 2012. It's like one of the oldest packages on Packagist. But before I begin, I have a quick pop quiz. And I assume if you're running this command, if you're running composer opt in a normal PHP project, what will the output be? And this is where you should usually raise your hand and say, oh, this will be the output. I assume that you said something like this, right? You always update this library. So short about me, I work at happy.com. I do plenty of Symphony stuff, and I do PHP meetups in Stockholm. And I am from Sweden, and that's probably why I say AWS instead of AWS. I didn't notice I was doing this until last week when a friend kindly pointed it out to me. I mean the same thing. Whenever I say AWS, I mean AWS. I also do plenty of open source. I usually show this slide and say, oh, I started open source in 2016 with PSR6 and PHP Cache. And nowadays I do plenty of other things as well. But most importantly for today and for this story, I work on Symphony. And I would like to start with Symphony. I'm really passionate about the Symphony Messenger. And about a year ago, it was a PR open, the one that include AWS SQS bridge to Symphony Messenger. So the Symphony Messenger is, by default, you can add things on RabbitMQ. And this PR wants to allow you to add things on SQS as well. So I reviewed this PR a few times, and I tested this a few times, and I started to privately chat with the author. And the author was Jeremy DeRoos, this guy. And the PR wasn't really big. It was only 500 or 600 lines of code. And most of it were handling authentication. Jeremy implemented 3 ways of authenticated with the Amazon services. But there are like 4 more ways to authenticate. So we discussed this, and we also discussed at the same time it was a PR on the mailer component, want to integrate with mailer, Amazon mailer. So this would mean that we will duplicate all the authentication logic in 2 components, or we had to do something smart to make sure that we reuse that code. And Jeremy and I also discussed to use the official AWS SDK for this, so all authentication was handled flawlessly. However, the official SDK has some drawbacks. First off, its size. Like the Symphony PR only did 2 HTTP requests. And if we require the official SDK, it will fetch 18 megabytes of code. This is over 37,000 lines of code. Not comments, mind you, code. And you also fetch Guzzle. I do like Guzzle. I am maintaining Guzzle at the moment. But in a Symfony application, you most likely already have installed the Symfony HTTP client. And no application needs more than 1 HTTP client. So it doesn't really make sense to download all this code, get 2 HTTP clients, just for sending 2 small HTTP requests. So Jeremy came up with the idea. Let's create a new SDK. And I'm always happy creating new things, but I was still hesitating. It's a massive job to build something like the SDK, the AWS SDK. But he said, since every AWS API has a big JSON file that defines all the inputs and all the data types and inputs and all the outputs, we can just look at this JSON file and generate the PHP classes needed. And I was amazed. I was really happy about this. So I started to build a native code generator, and soon we got a client that looked like it was working. And at the same time, Jeremy was focusing on the more difficult stuff, like implementing all the authentication, all the ways to authenticate. And we quickly have a core, and we also have an abstract API class. And all the client code was generated from this specification. And now we just started to make sure it was working properly. We were trying to we're adding more services. We added S3, SES, SQS, STS. And we added all these services because they work kind of different. And we want to make sure the architecture we were setting was working. And all these services, some of the services had accepted HTTP requests that was on JSON RPC, some required query parameters, some required REST JSON, some required just REST XML, And we also have to create response parsers that can parse the response from AWS services, which would also support REST JSON, REST XML, RPC, etc., etc. And at this point in the project, it's really challenged my way of thinking, because I remember at some point I was writing code to generate PHP code that took a PHP class to generating XML. So I was basically 2 steps away from the problem at all times. So instead of just writing the code that solves my XML code generator, I have to write code that generated code that solves my, I guess you understand what I'm saying. And being 2 steps away from problem is very unnatural, at least for me. And that's why I really enjoyed working with this. But from this point was basically, we improved things, we tested things, and then we iterated, just improve, test again, and we moved around a lot of code. Every small change in the generator generated about like 500 lines of changes in the generated code. And you can see this from the contribution graph. Like in the beginning, so much code was moved around, but for the past few months, nothing really happened, because we have nailed our architecture and we are pretty stable. And looking at this graph, it's quite interesting. It also shows how different of styles me and Jeremy have when we're developing. I feel like I'm more like a construction worker. I rush in trying to redo everything here, and then I get trying to redo everything over there, and just working all over the place at the same time, and doing things and then doing them over again because I changed my mind mid-sentence or whatever. But Jeremy, he's more like this artist, this elegant painter coming in with just a few strokes of a brush and just make things awesome, and in ways I couldn't even predict or imagine. So I had a really great time working with Jeremy on this. Some of the features that we felt was important. We want to have small packages, like only 1 package by client. We don't want to download hundreds or tens of megabytes of code. And we don't want to have updates every day. You should be able to read the change log if you update a package to understand what changes you bring into your application. We want to be something performant and want readable code. And yes, most of the code is generated. Yes, about over 80% is generated. But you can still read the code, understand the code, and know how to use the API. And don't get me wrong, I don't think the official SDK is bad. It just has different goals and priorities. And some has asked me, like, are we competitors? But I don't really think we are competitors, because Async AWS is just a way to help AWS to make you buy more of their services. So there's no rivalry between us. Quite the contrary. So I've been talking for a while now. How do you actually use it? How does it work? And I'm happy to tell you, it works as you expect. So let's take an example that I guess it's most likely you are familiar with. Let's install S3. So what you do is you compose require Async AWS S3. You're getting plenty of dependencies here as well. However, this is only 0.9 megabytes of requirements, 900 kilobytes. And most of these are polyfills and interfaces. These 3 packages is only code you're actually downloading. You have the Symphony HP client, and then you have a core package, and then the S3 one. And how you would use it, you just create a new S3 client, just like this. And then you let your favorite IDE help you to discover what methods to use. And these methods are named exactly the same as the official SDK. These methods are named exactly as the AWS CLI is doing, exactly as the API operation in the documentation. So these names are fetched from the specifications. And then when you have the method you want to do, I want to upload something, I just look at what arguments I can pass to this big array. And the ID can help you discover this. And then I fill in, I want to upload to this bucket, this key, and this body, and now I'm done. Now upload something. And that's basically it. And if you're more interested, hey, what other arguments can I use? Or what do they mean? If I click on this put object to see the definition, I get a big doc block like this. It has some 1 or 2 sentences about this operation, what it does. It has linked to the API reference, and it has a description of what parameter expects. And yeah. And if you are a seasoned open source maintainer, you maybe think, hey, this is horrible to maintain. because every time you add a new feature, you need to update the code, you need to update the documentation and the doc block. And if you have a large library, it will be inconsistencies eventually. However, this code is all generated, so we don't have that problem. But isn't passing arrays bad? Like, there is a handsome gentleman that's touring the PHP world at the moment, and he says, don't use arrays for passing as arguments or return values because it's bad because of reasons. And if you're one of those people that really believes that, which you maybe should, feel free to use objects. Like here, I've first the code I showed you, and then I use the put object request and set the bucket, set the key, and set the button here, and then I send it to the S3 put object. So you don't have to use the ugly arrays if you don't like to. In fact, what we're doing in the put object method, the first thing we do, we take this array or object input and make sure it's an object. And if you are not jumping up and down in joy this very moment, just sharing this and think this is awesome, that probably means that you have never really used the official SDK directly. You have never really been struggling with SDK and trying to figure out what to do and getting weird exception messages. And that's true. The official SDK also has nice auto-completion. This is the official one. But if I'm interested in, hey, what are the arguments I can pass to the get object? So I click on the get object function and I get to this wall of comments. There's too much magic here. Like it's basically only magic. And I believe it's super difficult to actually read the source code of the official SDK. And it's not because it's complicated. It's not because it's written with such fancy or advanced PHP so I can't understand it. It's basically because I cannot find the source code. I really don't know where the next line is when I'm executing the get object function. I have no idea how to find the arguments of the array args here. And the benefit of having real classes and real objects like Async AWS does comes through when you unit test things. You can unit test any client. All the clients, none of the clients are final, and all of them have all their function defined. There's no magic. So writing a unit test for a file uploader is you do as you normally would. You do exactly as you would expect. You get the mock builder to mock the S3 client. You say you want to mock the put object method. There's maybe something magic with the result mock factory that you want to, the result of the put object method is a put object output, and you use the result mock factory to create such output, and then you just validate the input as you normally would. And if you ever been trying to use a unit test and test the official SDK, you know that you would first create the S3 client, and then you give it a custom Guzzle client, and that custom client should have a mock handler. And with the mock handler, you can define what PSR7 request and PSR7 responses you expect and want to return. So you're going in the deep internals of the AWS clients to go to the internals of Guzzle, and that's where you mock things. So I'm trying to say this works just as you expect, and you do everything as you normally would. And if you want to be fancy to have different properties of the get object output, you can just pass an array here saying, I want the last modified property of the get object output to be in a datetime. And you can specify bodies like this. This last modifying body are properties of the get object output. I've been talking way too long now without addressing the elephant in the room. The official SDK is not all synchronous. It also has some async requests. And so what about async? What makes Async AWS async and not the official one? Generally, asynchronous stuff is really hard to work with, or they are at least more complex than synchronous stuff, as this graph shows. So what we've been trying to do, we hide all the complex Symphony async stuff in the Symphony HTTP client. And the only thing Async AWS is doing is basically a smart integration with the Symphony HTTP client. And the idea or the goal or the result is that most of the time using Async AWS, you don't really care if it's async or not. And the reason we want to do this, all this trickery and all these weird things, and yeah, the reason we want to do this is because HTTP is really, really slow. And we want to build a fast library. So the solution is to do as little HTTP as possible. And that's why we do async stuff. So if you don't care of any async stuff, you will only benefit from this because it's a little bit faster. And I can show you this by an example. So say you wanna copy a file on S3. So you create your S3 client and you wanna copy the cat.org.jpg into catnew.jpg. And you don't really care about any of the request, any of the HTTP response body, right? You don't care what every metadata is there or what the ACL looks like or whatever the HTTP response body contains. You just want to make sure this file is copied. So this piece of code will do exactly that. And the copy object, the last line here, that will make sure they will, if everything's fine, it will just return an output. But if there's any issues, it will throw an exception. And it will basically only download the first line of the HTTP response and look if it's 200. If it's not 200, throw an exception. And I want to show you the principle how we made this work. And if I had a live audience with a stage, I will see if you nodded or not, but I assume you slightly nodding at the moment. So I want to show you the basic principle how this is working. So the copy object method, we will return a copy object output. And sometimes these are called output, sometimes these are called result, and it depends on what service you're using. AWS is super inconsistent between APIs. In S3, they're called outputs. So every output has a list of properties and a list of getters. And all this data is from the HTTP response. You also have a response class. So whenever you want to get if you call the get expiration, we call the initialize function first, which makes sure that we resolve the response and we download the response body and add it to the properties of this class. Make sense? And the response class itself has a destruct method, which means that the destruct method makes sure to resolve the response if it hasn't been resolved before. This will guarantee that you always send the request and you read the status line of response. There are no scenarios where you think you sent the request, but nothing really happened. And the resolve function is basically only downloading the first few, the first line of the response and make sure it's a 200. If it's not 200, we throw an exception. This is of course a simplification, but an early version of the library were something like this. Since then, we added a few more edge cases and we refactored stuff and we added some performance optimizations. So the consequence of this, like how this affects real world usage, is that if you have a code like this is the SQS client, we want to just put a message on the queue, and the send message that will create an output or result, and that result will be created and immediately destructed because we never store it anywhere. So the request is actually sent on this line. If we slightly change this example to look something like this, we save the result in a variable called result, and then we actually trying to access a property of this result. The request is actually sent on this line. This line sending request, and we're parsing the response. And in the vast majority of the cases, you don't really care, right? I mean, you can only see this behavior if you expect this with Xdebug, but it doesn't really care if the request is executed on this line or the second last line. There is one small issue, one edge case with this. If you have this code in a block, so I have a block function called send SQS message, it sends a message, it saves the result to a variable, and then you have like 100 lines of business logic, and you never use the result variable, and then you end the block. This means that the request is actually sent on this line when the result variable is destructed. And yes, this can be a bit confusing, and especially confusing if this throws an exception. So you have 100 lines of business logic, and then an exception happened with something that's not even close to sending a message. And you can easily solve this issue by just not having a unused variable, just doing like this. Another way is to destruct the object, or you can use the resolve function. The resolve function is good when you want to do non-blocking things, want to control your timeouts. In normal use cases, you don't really need to use resolve. You maybe want to have it if you want to try catch things, but normally you wouldn't really care about resolve. And if you really want to be async and do things in parallel, yes, you can. Like, sure, PHP is single-threaded, but we used Symphony HP client, and Symphony HP clients using curl, and curl is written in C, and C can do things in parallel. So again, all the greatness and awesomeness from async actually comes from the Symphony HP client. So let's do another example. Say you want to search your log files. You want to search log files for something. So you want to download the latest 100 log files and then just parse them as quick as possible. What you can do is something like this. You create your S3 client, you download all your log files, and then you use for each results wait. And the first iteration of this loop will actually give you the response, the log file that was first downloaded. Has nothing to do with the order you created the request in. It would get basically the smallest file first. And then you just parse it, whatever you want to, business logic you want to add to this content of this file. And this parameter is null. This is used if you want to set a timeout. Say you only care about responses that are downloaded within 2 seconds. And the last parameter is true if you want to download the full response and then iterate over it. If it's false, like it's by default, we just take the request that first got the response, not that we download the first status line, not the full response. There are scenarios where you want to make a difference between these. And don't get me wrong here. This is not super sexy. I really know. However, this just works as you would expect it to work. Everything, I mean, if you had a magic wand and wished for something, it just works. Say pagination, for instance. This is the CloudFormation client. You can give me the first 1,000 stacks, or give me all the stacks I got. This request will give you the first 1,000. And when you have listened to 1,000, when you have iterated over 1,000, this line will automatically fetch the next 1,000 stacks for you. I mean, everything just works. And don't get me wrong, we fought hard to make sure it works this way. I mean, we've been battling PHP Stan and PHP and Salm not to make sure that our data and variables are correct. We want to make sure that we want to make sure that Salm knows about what data types we're using. So when someone is using the library, you can just flawlessly integrate with that, and Salm can warn you if you're doing something wrong. And we apparently, I think the last 6 months, I think we opened about 7 issues on these, or 7 issues or on PHP Stan and Salm. Most of them are closed because we were doing weird things, but we find some really edge cases in PHP Stan and Salm. We also worked with PHP Storm to make sure that code completion works properly. And of course, we have tons of these integrations with other known things. And I know I was the first one doing an integration with Fly System version 2, because I had to email Frank de Jong and say, hey, where is the source code? You've been talking about it, we never showed the source code, and he had it hidden away somewhere. So we have Fly System integration, Laravel, and some Symfony bundles, etc. And we have a simple S3 client which makes it easier for you if you want to upload or download files that are larger than 5 gigabytes, because there's a limit apparently. And I assume the only question in your mind right now is it safe to use? Like, this library was created by 2 random people for 6 months ago. And you compare that with the official SDK, which is backed by like the world's largest company, and which is more safe to use, which is more riskful to use, or like what happened if someone disappears, like if Jeremy and I disappears, like will this go extinct, this library? So what we have done, we've been discussing this, and we understand this is a major feature or issue. Like this is something we need to address. So we have a lot of CI and a lot of checks, as normal open source libraries should. We have one check, for instance, that says if you try to modify any of the generated code, the CI will fail. It will recognize this and give you like, hey, you shouldn't do this, you should update the generator instead. And we've added 3 extra maintainers, and they promised us that they will take over the project if Jeremy and I disappears for some reason. So that's some extra safety there, I guess. And we also have the same BC promise as Symfony does, and we have a very strict BC checker script that makes sure we don't accidentally break our BC promise. And we have tests like any other good open source project, and we try to automate everything. Like we have a bot that checks the specification every day, that it looks if some of the official specification has changed and that affects our generated code, this bot makes sure to update the generated code immediately. So maybe once every week we got a peer like this, and we basically just merge it. Most of the time it's the fixing typos in or updating documentation. And we also have, I mean, this is a page from the README. I'm really happy about the very right column. It tells us how many commits that were made that has not been released yet. Because this shows our 15 AWS clients or 15 packages. And it's 15 packages, quite a lot to manage in your head. So we cannot remember if we merged a feature that should be released. So we don't want someone to say, hey, you forget to release this PR I made 6 months ago. So we have this dashboard to show us like, hey, maybe this SSM client, it has 6 commits, it maybe should be released now. So, and also, this is the 15 clients, AWS clients we have and we're using. The official SDK has over 200 clients. And sure, I can challenge you to name one client that's not on this list. This is basically the ones that are being used most. The ones Jeremy and I was using, the ones we needed for open source libraries, and the ones other users have been requesting. And if something missing, please contribute. Like we have a policy to always say yes to generated code. If you say that I need this client or I need this operation, we always say yes. There's no reason we say, oh no, it's not very, very heavily used, etc. And with that said, we don't want to just generate all just because of it, because it's no point of having code that nobody's using. Even though it's generated, even though it works perfectly and it's tested, having code that nobody's using there's no reason to it. But if you feel like, hey, maybe I want to have the get bucket ACL operation on S3, you just run the generate S3 get bucket ACL, and you say, yes, I really do want to add this. And a few seconds later, do a git status, and you have a bunch of new files. And we have modified the client, and we have also given you a good base on integration test and unit test. So the only thing you need to do now is make sure the test is passing and you're ready to make a PR. So is it safe to use? Yes, I really, really do believe so. Thank you very much. Oh, if you have any questions, I'm happy to take them here. There is a...
we have, sorry, Tobias, I was going to say we do have some questions. Can you see the Q&A panel there?
No, but I can shut down this and I can have a look.
Okay. So we have the first question that came in was, does this implementation of the client also have a contract for itself? Okay, do you have a PHP interface?
No, we don't have an interface. That's a great question. That's something we were discussing, because we really were, since you do open source, you really want to have final classes and add an interface because it makes things easier. However, if we add an interface, that means that we cannot add a new method to that interface because that's a BC break. So every time we're adding a new, if you're generating the get bucket ACL, it means that we had to release a new major version. And that's why we don't have interfaces for clients, because it's impossible to keep that contract.
Great, yeah. Okay, so the second question was, is there some performance comparison with the official SDK?
Yes, or we have done some performance comparison, and it's, since you're doing HTTP, it doesn't really matter how quick of a client you're using. It's only matter how quick your internet connection is, because even though you run a fraction of the code and your PHP is super quick, as soon as you're doing HTTP, all that performance optimization is neglected basically. So we are a little bit faster on some requests because we don't download the full response. Most of the time we don't download the responses is on small responses. So technically we're faster, practically we're about the same.
Okay,
if it makes sense.
Yes, and then I'm sure a question that a few people are thinking right now as well is, how much work would it be to convert from the official SDK to Async AWS?
Oh, that's an excellent question. For the past 3-4 months, I've been converting all my applications to using Async AWS, and I've been using Fly System a lot. So that was basically just change out the integrations and adding a few config files on my Symphony application. And we basically using more or less the same namespaces. So sometimes you just modify the use statement at the very top. Instead of AWS S3 client, it's Async AWS S3 client. And then you slightly modify the arguments to the methods. And sure, there are other things like if you want to read the response from the official SDK, you always get a mixed return type. And in our client, you actually get null or a datetime interface, or null or an integer, or something that makes sense. So it's more type safe. So what you need to do is you need to, in your current code, you probably have like assume this mixed type is a datetime and work with it. And using our client, you need to make sure, is it null? No, it's not null. Then I know it's a proper data type. So it's, you're basically just removing 10% of the code, and it's fairly simple. It's fairly simple, yeah, especially since you have documentation on the methods now.
Excellent. Right. Thank you very much. I think that was a wonderful presentation. I love the kind of premise behind this project that, you know, like you say, what's the point in downloading all of that when I just want to make some requests?
Yeah.
You know, all of these extra dependencies into your project, and in the world of cloud computing, where everything's going much needs to be much smaller, much more focused, then you know, these kinds of differences are important.
That's actually a major deal breaker for me. I'm developing everything on Bref, everything on Lambda. That's where I'm hosting my applications. And Lambda has a limit how large your applications can be. And not downloading 18 megabytes of code is actually a great relief. And some application I was using Cilius, which has a lot of dependencies. And switching to Async AWS made sure I can actually upload my application and run it on Lambda. So file size do matters, and especially if you're doing Docker deployments, stuff like that as well. Yeah.
Yeah, of course. Right. Thank you very much for your talk today, Tobias.
Thank you.
Okay.
We do have a website which has all documentations and covers some more features that I didn't mention today. And the website is very compact and easy to read, and it's probably full of spelling mistakes as well, because I can't really spell really well. So check it out, and feel free to correct the English if you like.